Now, the variable t is the explanatory variable, as we can change it. Okay, the explanatory variable is often referred to as the independent variable. We can change this, we can change temperature, and what's going to happen then is that V, the noise, is dependent on that temperature. And this helps us with the next part of the question, actually, because when you generally plot a graph, okay, we have our axes like so. Now, normally we call this x and y. Y is the dependent variable, x is the independent variable. So for something like this, if we were to plot the regression line, then t goes here, it's the explanatory variable or independent variable, and v goes up here, it's the dependent variable. So, as I say, this brings us into the next part. Why is it possible to use the form for the regression line? So this brings us to the next part. Why is it possible to have a regression line then to model this of the form V equals A plus BT? Remember, we'd have our points scattered about this line. Well, the reason is we've got a high product moment correlation coefficient close to 1, so we can say for part D that since R is close to 1, okay, is close to 1. Remember, its value was 0.808, we found out in an earlier part, okay. Since R is close to 1, we can expect, okay, linear correlation, positive linear correlation. I don't know why I'm writing an H there, but linear correlation. And we know that if this had been, say, y and x, our line would have been of the form y equals a plus bx. But now we've seen that t is the independent variable, the dependent variable instead of y is the v, so this clearly supports that case for that model then. High correlation coefficient and the fact that t is our explanatory variable. Okay,